high school math. Just hearing those words can make some people break out in a cold sweat, right? But what if it wasn't just about memorizing a bunch of formulas? Well, today, we're diving into 7 really powerful strategies that can help transform math from a chore into a creative puzzle. So let's just start with the big question. Is math really more than memorizing formulas? The answer to this is absolutely key if we want to shift students from just doing math to actually thinking like a mathematician.
You can kind of think of it like this. There are 2 sides to the mathematical coin. On one side, you've got the skills. That's the what, like arithmetic and algebra. But equally important, on the other side are the processes. That's the how and the why. This involves things like problem solving and logical reasoning. To really master math, you've got to have a balance of both.
Okay, so how do we actually build that balance? Our first set of strategies is all about creating a rock-solid foundation, and that starts with deep conceptual understanding.
First up, strategy number 1. It's all about giving math a purpose. It's about focusing on clear, understandable mathematical goals for every single lesson. Because when students get the why behind a lesson, they start to see how each little problem fits into the bigger picture. This helps build knowledge on a really deep understanding, not just memorization. And it encourages them to try to solve things on their own before just reaching for a calculator.
And from there, we can build on that sense of purpose with our second strategy, really fostering reasoning and problem-solving skills.
This one is huge. It's all about shifting the focus from just getting the right answer to understanding the entire process. And what's so crucial here is that this builds resilience. It encourages students to persevere, to stick with it, and to discover that, hey, there's often more than one way to tackle a single problem. Our third foundational strategy is all about making abstract math feel more concrete. And we do that by connecting different mathematical representations. And we can do this in 5 really powerful ways. You've got physical objects, like blocks or tiles. Then there are visuals, like graphs and number lines. And of course, the symbolic language of equations. But it also includes verbal discussions and, so importantly, connecting it all to real-world situations. Using a mix of these really helps students see a problem from all sorts of different angles. Okay, so once that foundation is in place, our next group of strategies is all about putting that knowledge into practice, and that means active student engagement. And here is a strategy that can completely change the energy of a classroom. Number 4, encouraging mathematical discourse. Now, discourse is just a fancy way of saying get students talking about math. It's a space where they can compare ideas, build arguments, and even critique each other's reasoning. Constructively, of course. A simple but incredibly powerful way to do this is something called think, pair, share. It gives everyone a moment to process on their own before they team up and collaborate. Strategy 5 is about mastering the art of the question, moving way beyond questions that just have one right answer. So how do you do that, right? How do you frame a question that actually opens up a conversation instead of just shutting it down? Well, the secret isn't just asking open-ended questions. It's really about creating the right environment. So for example, instead of asking what's the answer, a guiding question could be, hey, can you walk me through your thinking here? You feel that shift? It's patient, it's non-judgmental, and it invites a real conversation. It encourages students to take intellectual risks.
Our 6th strategy tackles a classic debate, practice versus understanding. Where's the right balance?
The key is to develop procedural fluency from a conceptual understanding, and this quote just says it all. When students only memorize procedures, that knowledge is, it's brittle. True fluency means you can not only perform the steps, but you can also explain why they work. That's when it really sticks.
All right, finally, let's look at our last strategy. This is the one that's all about closing the learning loop and making sure there's continuous improvement for everyone in the classroom.
Our final strategy really ties everything together. It's all about using assessment and monitoring not just for grades, but to actively support the learning journey itself. This means we kind of have to reframe what an assessment is. It's no longer a final judgment, it's a tool. A great assessment focuses on the application of knowledge, helps students track their own progress, and gives educators the feedback they need to adjust their instruction. It becomes an active and even positive part of the whole learning cycle. So, when you combine all of these strategies, you create this incredibly powerful shift. A shift from a culture of just getting answers to a culture of genuine problem solving.
And this brings us to the ultimate takeaway. A simple but really profound equation for mathematical thinking. The method, plus the answer equals a true solution. That idea, that is the very core of what it means to think mathematically.
So that leaves us with one final question for every teacher, parent, and student. How will you use these ideas to help build the next generation of mathematical thinkers?